All right, today we are talking about our final conic. We are talking about hyperbolas today. A hyperbola is a set of all points in a plane such that the difference of the distances from the two fixed points is a constant. Okay, so again, here's kind of what your picture looks like. In a second, I'll shove down and I'll show you the standard form, but I did want to just kind of look at it with you right here while we're looking at the picture. Okay, so you'll notice it looks very similar to the equation of an ellipse, except that it is subtracted. So you kind of see this idea where here, since we have nothing added or subtracted to the x and y, our center is at 0. And then you can kind of see that, the a was under the x squared, so the a squared was under the x squared, so I went out a in the x direction, and I went out b in the y direction because b was under y. And then you'll see I made this, like normally with an ellipse, we like connected those 4 points, right? Well, here in a hyperbola, that is going to be an outline. I'm going to connect those dots, and then that's the kind of outline I use to draw in my asymptotes. So when you have the box, your asymptote is going to cross through the center and each corner of the box, and then that's going to kind of give your curve its shape. Let's see, what else was I going to say? We also have the foci like we always do. We're going to use a different formula again this time to find our C. But again, it's always C out from the center. And then you'll see that we have our equations for our asymptotes. And it's always, B plus or minus B over A. And again, this gets a little confusing, but when you start looking at examples, it clears up a little bit. Okay, so we have two different forms of this, just like we kind of have two different forms of all of our of ellipses and parabolas. So when we have our leading x squared, then that's when it opens to the side. And when our y squared is leading, that's when it opens up and down. Notice that in this case, it doesn't matter which one is a squared and b squared. It's all dependent on which of the variables on top is positive. So notice you have a subtraction here. So if the x squared is the leading variable and it's positive, then you're opening to the right and left. If the y squared is leading, then you're opening up and down. But again, that a squared and b squared, it doesn't matter which one's bigger in this case. So again, you're going to see, sometimes we have x-intercepts. In the vertical case, we wouldn't have x-intercepts, vice versa for our y-intercepts. So again, we'll walk through these. Now, one thing I did want you to notice is that remember on our ellipse, the way that we found C was the difference between a squared and b squared. Well, in this case, when the function is subtracted, we are going to add the a squared and b squared to get C. And again, if you think about this, it kind of makes sense because for our ellipse, the foci had to be inside the ellipse. And then for the hyperbola, those foci are on the outside. So we kind of need to, it's going to be further apart. So that's why we're adding. But the way I really like to think about it is in the function that's an ellipse where I'm adding the two fractions, it's subtracted. And in a hyperbola, when I'm subtracting the two functions, the a squared and b squared are added. Okay, and let's just start looking at some examples, and I think it'll make more sense. Okay, so notice the other thing I want you to pay attention to here is that for hyperbolas, we are always going to use 0, 0 as our center, okay? These get a little messy, and so we're going to just keep it simple like that and let 0, 0 be the center for all of these hyperbolas. All right, so the first thing we're going to do is we're going to find the vertices, decide whether we have x-intercepts or y-intercepts, find the foci, and then write the equations of the asymptotes. Okay, so again, just like an ellipse, I usually don't write any of my information up here until I kind of go down here and start plotting it. So since the x is leading, that means it's going to go out to the right and left. So I'm going to go out 5 to the left and 5 to the right because that a squared is 25, so a is 5. And then, and the the b squared is 36, so it's 6. Now, I'm just going to barely put points here because there's actually not points at this point. It's not like our vertices and co-vertices. We need these points right here to help us draw in our box. Okay, because I told you we're going to draw in that box, and that box is going to help us draw in the asymptotes that's going to give our hyperbola its shape. So then we can go ahead and draw in the asymptotes. We're going to just connect one corner of our box to the other going through the center. So again, we're going to connect the two corners of the boxes. So if you're ready, we could go ahead and write what the equations of the asymptotes are. It is always going to be y is equal to plus or minus, because notice we have a positive slope and we have a negative slope, and then it's just going to be the rise and run. So 1, 2, 3, 4, 5, 6. We went up 6 and over 5. So 6 over 5x. Okay, so here, because we went out right and left, because our x squared was the leading one, these are our vertices. So you can either write it as 2 points, or if you want to just write plus or minus 5, 0, that shows me that there's the 2 points, there's the plus 5, there's the minus 5. So notice in this, because of the leading x squared, we have x-intercepts. We do not have y-intercepts. Okay, and then the last thing that we need is our foci. So again, we're going to say, all right, c squared. Now remember, with an ellipse we subtracted, but with a hyperbola we're going to add. So it doesn't matter the order in which the a squared and the b squared come. So then we have c squared is equal to 61 square root of 61. So c is equal to plus or minus root 61. So we have plus or minus root 61 comma 0. And then root 61, it's a little shy of 8, right? Because the square root of 64 is 8. So we're just going to go out 6, 7, and then just put it just a little less than 8. 6, 7, just a little less than 8. And those are our foci. And then we're going to just use those asymptotes to kind of help us shape the curve of this hyperbola. So it's kind of going to curve out. Looks like little parabolas kind of going to the right and left. Okay, that's all we have for this one. Okay, so number 2, we see that this time our y squared is leading. So that means it's going to open up or down. So again, we just kind of use those denominators to figure out how far we go out. So on the y-axis, the square root of 16 is 4. So that means my a is 4. So I'm going to go 1, 2, 3, 4. Now these are the vertices, so I'm going to go ahead and give them good points. And then I'm going to go out 6 on the x. And again, those aren't going to be points. I'm just going to use it to draw my box. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Okay, and now I'm going to draw in that box. And then I'm going to connect the corners with my asymptotes. Okay, and so we can go ahead and write our vertices. This time we have vertices at 0 plus or minus 4. And again, notice that these are y points, so I made sure and put the point in the y y spot. And then here we have y-intercepts and no x-intercepts. We can jump down and write that equation of the asymptote. So we have y plus or minus. Now we go up 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6. So think about that, 4 over 6, that's our slope, which reduces to 2/3. So then we could just say we have y equals plus or minus 2/3 x. And then finally, our foci, we're going to take c squared is equal to 16 plus 36. C squared is equal to 52. Square root, c is equal to, that does simplify. There's a 4 and a 13, so it'd be plus or minus 2 root 13. So I've got them, and again, make sure that these are on the y-axis. So I put a 0 for x, and then I have a plus or minus 2 root 13. All right, so again, we kind of go back to that square root of 54, or you put it in your calculator, whatever works for you. So square root of 54 is a little over 7, right? Because 7 squared is 49. So we're a little bit above that. So there's 5, 6, 7. So we're a little above 7 for that foci. And a little below, sorry, right there for that one. And then again, we just use the asymptotes kind of as a guide for the shape of the hyperbola. Okay, so now our next one, we see these are not in standard form. So the first thing we're going to do is we're going to move whatever term needs to be moved. And then, just like an ellipse, we have to divide by that constant on the right because our equation is supposed to equal 1. So the first thing I'm going to do is I'm going to move my 3x squared over equals 12. Now I'm going to divide both sides by 12. And then I have y squared over 1 minus x squared over 4 is equal to 1. All right, so my y squared is leading, so that means my vertices are going to be on the y-axis. So they will be at 1 and negative 1. So we can go ahead and write that. 0 plus or minus 1. So we see that these are y-intercepts. Now we're going to go out, the square root of 4 is 2. So we're going to go out 2 to the right and 2 to the left. Remember, those aren't exactly points, but they're going to help us draw in our box for our asymptotes. So again, when I draw in those asymptotes, all I'm doing is connecting the corners of the box with the center. So we can also stop right now and say what our asymptotes, the equation of our asymptotes, we have a rise of 1 and a run of 2. So we have y is equal to plus or minus 1/2 x. And then finally, we'll have to kind of slide down here to find our foci. So we have the square root of 1 plus 4 c squared equals 1 plus 4, c squared equals 5, square root, c is equal to plus or minus root 5. So my foci are at 0, plus or minus root 5, and plus or minus root 5 is a little bit more than 2 because we know 2 squared is 4. So we'll go up to 2 and just a little bit over, down to 2 and a little bit over. And then we just use the asymptotes to draw in the curve. All right, our last hyperbola. So again, we see it's not in standard form because it's not equal to 1. So we're going to start by dividing both sides by 16. So I get x squared over 4 minus y squared over 16 is equal to 1. Right, my x is my leading term, so that's where my vertices are going to be on the x-axis. So the square root of 4 is 2. So my vertices are going to be at positive and negative 2. So plus or minus 2, 0. That makes these x-intercepts. Then I see that the b squared is 4, or sorry, b squared is 16, so b is 4. So 1, 2, 3, 4. And again, not really putting points there, just kind of giving it a little dot. But that will help me draw in the box for my asymptotes. Okay, so now I'm going to draw in the asymptotes, connecting the box. Sorry, that line was a little crazy. And connecting the other corners. So we can stop and say, what is that? Asymptote, we rose 1, 2, 3, 4 and ran 2. So 4 over 2, that would be 2 over 1. So y is equal to plus or minus, and then 2 over 1 we could just say is 2. So 2x plus or minus 2x. And then lastly, we got to find our foci. So we have c squared is equal to a squared plus b squared. So 4 plus 16. c squared is equal to 20, square root, so we know that we have a 4 and a 5, that's a 2 and a 2, square root of 20 is plus or minus 2 root 5. So again, our foci are at, since it's on the x-axis, it needs to go in the x spot, 2 root 5, 0. And then square root of 20 is kind of in between 4 and 5. So we'll go over here and we'll go 2, 3, 4, kind of somewhere in the middle. 2, 3, 4, right around there. And then just draw in the curves of the hyperbola. So we have covered all 4 conics now. So we want to take a second and just kind of look at how do we know which one is which? How do we know, what information is important about each one? And just kind of, general information like that. So we look at this and we say, okay, well, how can we tell if we're given this general form of our conic, which we started talking about, way back in circles. And so a couple things that we know. If A and C are the same, so the coefficients on your squared terms, and they're both positive, then it's a circle. Okay, and I guess it could be negative if they were both negative, but again, they have to be the same sign. So A and C are equal, and it's a circle. Okay, if A and C are not the same, but the signs are the same, so they're both positive, or again, they both could be negative, and then when we divided, they would be positive. But again, A and C not the same, but with the same sign, it's an ellipse. If A and C are not the same, but they have different signs, then it's a hyperbola. And if one of them, if there is no squared term, like if one of them isn't a square term or doesn't have a square term, then it's just a parabola. So again, remember, if there's only one squared term, it's a parabola. All right, so like I said, only one square term parabola. The sum of square terms is either a circle or ellipse, and you're going to look to that coefficient. And then if it's the difference of squared terms, then it's a hyperbola. Okay, so if either the x or the y is linear, so the only one that is linear and has another one that's squared, that's the parabola. Okay, if both x and y are squared or quadratic, and x squared is added to y squared, and the coefficients are the same, so positive squareds, coefficients the same, and they're added. So the ones that have the coefficients that are the same, that's the circle. If both x and y are quadratic and their coefficients are different, that is our ellipse. And so finally, if we have quadratic terms and they're subtracted, then that is our hyperbola. Oops, forgot the can't spell today. Excuse me. Hyperbola. Excuse me. Okay. Now, so this makes it easy when we kind of look at those general forms. Knowing these rules, we can quickly identify. So I have a 4x squared and a 4y squared. So they're both positive, they're both squared, and they're the same. So it has to be a circle. All right, here I'm looking for my squared terms. I have an x squared, but I only have one squared term. So automatically, I know it is a parabola. All right, I have two squared terms. They are added, and their coefficients are different. So that's the ellipse. Two squared terms that are subtracted. So that's subtraction. That tells me it's a hyperbola. All right, so again, we see a squared term and a squared term. They are added and they are different coefficients. So when they're added with different coefficients, that's an ellipse. Okay, now when you look at this one, kind of right off the bat, it sort of looks like it could be a, they're both positive, but remember that the square terms have to be on the same side in order for you to know if they have the same sign. So when I subtract that 16y squared, now all of a sudden I have 25x squared minus 16y squared. So that minus tells me it is a hyperbola. And then finally, our last one, I see I have an x squared, no other squared terms, so only one squared term is a parabola. All right, so finally, kind of putting it all together. So looking at and determining which one is which, and then finding all the specific given information. Okay, so we're going to determine if it's a circle, we need the center and the radius. If it's an ellipse, we've got other stuff. So again, just kind of looking at determining which formula it is, and then getting it into the standard form for that formula, and then figuring out our information. Okay, so we look here. I see one squared term, so I know this is a parabola. Okay, and so remember that parabola form, and I say, okay, well, this one is a y squared. So remember that parabola form is kind of that x minus h, well, in this case, and then it's the 1 over 4p times y minus k squared. Okay, so that's kind of that general formula. That's what we're trying to get this to look like. So because my squared term is negative, I'm going to move my y terms over to the right because I really like to have a positive y term whenever I am when I'm kind of completing the square. So I'm going to leave the x and the constant over here, and I'm going to move the 4y squared and the 16y over. So that's going to make that a positive 4y squared and a minus 16y. All right, now we know when we complete the square, we cannot have a coefficient on the square term. So I'm going to factor that out, GCF, and then I have y squared minus 4y. And now remember, this is where we do our plus blank. And remember, I need a plus blank on this side too. So I take half of negative 4. That is negative 2 squared. That is 4. So I'm going to put 4 here. Now, guys, remember, when you have a GCF out front, it's not just a 4 that I added. I really added 4 times 4. So I added 16. So I need 16 on that side. So then I combine my terms over here. I have negative 3 plus 16 is positive 13. And then I have 4 times y minus 2 squared. All right, so then I want to kind of think, okay, is this set up right? Well, I have the coefficient in front of the squared terms, insert in front of that squared binomial, and then my other constant is over here. So now I can go up and I can give all the information that it's asking for. So my vertex is the first thing it wants to know. So remember, you're going to always change your signs when you're plugging in for the vertex. So it'll be negative 13 and positive 2. Okay, the next thing is my axis of symmetry. Now, y'all, I will be fully honest that I have to kind of picture this whenever I'm looking at it. And I say, okay, it's a positive y squared. So a positive y squared is going to open to the right. So this sort of helps me figure out, okay, what is this going to look like? Well, if it goes open to the right, then remember my axis of symmetry is going to be that y equals line, and my directrix will be an x equals line. So that just sort of helps me get it in my mind. So my axis of symmetry is going to be y equals the y value of the vertex, y equals 2. Okay, so now we need to think about where would our focus and directrix be. Well, remember that this coefficient on our squared parenthesis is that 1 over 4p. So 1 over 4p is equal to 4. So I need to solve this. I can multiply through by 4p, and I get 1 is equal to 16p. Divide by 16. 1 over 16 is equal to p. Okay, so what that means is 1 over 16 this way and 1 over 16 that way to get to the directrix. So this is going to be a small change. So if I'm at negative 13 and I'm going to the right 1/16th, my focus is going to be negative. We can just say 12 and 15/16. And again, the y value wouldn't change. It would be at 2. And then my directrix is going to be the x equals line. And again, it's going to be 1/16 to the left of the vertex. So it's going to be x is equal to negative 13 and 1/16. So there's all of my information for this parabola. Okay, looking at our next one, we look at our squared terms. We have positive squared terms. They have the same coefficient. So this tells us it's a circle. Then we look and we say, okay, well, oh, and there was a typo here. We're going to pretend that that's the 36 because it doesn't really work out well if it's not. Okay, so now if that is a 36, then we are able to divide all of this by 9. So that's going to be x squared plus y squared. That'll be plus 4x plus 2y plus 1 is equal to 0. Now we need to group our x terms and give ourselves a plus blank and group our y terms. So we have x squared plus 4x plus blank plus y squared plus 2y plus blank. And then we move that 1 over, so it'd be a negative 1 plus blank plus blank. Okay, so now I'm going to go over here. I'm going to take, let's do it here. Half of 4 is 2, and 2 squared is 4. Sorry, kind of got cut off. So I'm adding 4 there, and I'm adding 4 there. And then half of 2 is 1, and 1 squared is 1. So I'm adding 1 there, and I'm adding 1 there. Then we know that when we complete those squares, that next term or next kind of line is the binomial squared. So I have x plus, now remember it's whatever the term that you squared, so x plus 2. And then y, what did I square? I squared a 1 plus 1. And then combine my constants over here, a negative 1 and a positive 1 will cancel, so I just have it equal to 4. So then what do we need in our circle? We need a center and the radius. So our center, we change the sign, -2, -1, and our radius, remember this is r squared is equal to 4, so r is equal to 2. Number 3, we have 2 terms squared with a minus, so this makes this a hyperbola. So again, we know that a hyperbola has to equal 1, so we're going to divide both sides by 144. Now that will reduce, that 16 over 144 will give me x squared over 9. And then y squared, that 9 over 144 is going to give me y squared over 16. And again, that will be 1 on the right side. Now, for our hyperbola, we need the center, the vertices, the equation of the asymptotes, and the foci. So our center, remember, if I'm not adding and subtracting, which all of our hyperbolas should always have a center of 0, 0. Our vertices, now remember, we figure out, okay, it's always the first term, so it's an x squared, so that means we're going out to the right and the left, and then a squared is 9, so that means a is 3, so we'd be going right and left 3, comma 0. Now, this part takes a little thinking, and again, sometimes I have to sketch it, so I'll sometimes sketch this, and I'll say, okay, if I went out 3 here and out 3 here, and then I rose 4, then what would be that equation of the asymptote? Well, it would be 1, 2, 3, 4, 1, 2, 3. So 4/3 would be the equation of the asymptote. So y is equal to plus or minus, we rose 4 and ran 3x. And then finally, our foci, So because, again, I remember it by thinking, okay, the two fractions are subtracted, so it's c squared is equal to the opposite of that. I'm going to add the a squared and b squared. So c squared is equal to 25, square root, c is equal to plus or minus 5. And again, it's whatever axis the vertices are on, so the foci are also on the x-axis, so plus or minus 5, 0. Okay, so that leaves us one more. The only other one we haven't done is an ellipse, so let's make sure we have positive x and positive y, and they have opposite coefficients. So this is our ellipse. So we have to get it in that standard form for an ellipse. So we're going to start by grouping our x terms and our y terms and then factoring. So I've got 9x squared. Well, I guess we have to factor a GCF and then we will complete the square. So again, just starting first by grouping, and then I'm also going to move that 144 over to the right. All right, so now we factor out a GCF, so we have 9, and then we're going to go ahead and give ourselves a plus blank here. So we have x squared plus 8x plus blank. And then here we got to factor out that 25 because I can't do completing the square with a coefficient on my square term. So then I have y squared, and then 150 divided by 25, that gives me minus 6. Y, and then plus blank, and then again we have our negative 144. Kind of ran out of room. We're going to have a plus blank and a plus blank. Okay, so we go over here and we're going to say, all right, what's half of 8? That's 4 squared. That is 16, so I'm going to add 16 here. Now remember that it's not just adding 16, I'm adding 9 times 16. So that is 144. And then I'm going to take half of negative 6 is negative 3. Squared is 9. So I'm adding 9. But again, I'm not just adding 9. I'm adding 25 times 9, which is 225. Okay, so now I can kind of group. I know I'm going to go after my completing the square or my plus blank stage. I go right to that binomial squared. So x plus 4 squared, because 4 was what I squared. And then 25, and then I have y, and then what was the number I squared would be minus 3 squared equals. So my negative 144 and my positive 144 cancel out, and I just get 225. And now I know that in an ellipse, it's got to be equal to 1, so I'm going to divide both sides by 225. So I'll reduce those fractions. So 9 over 225 reduces to x plus 4 squared over 25. And then we have y minus 3 squared. 25 and 125 reduces to 9 is equal to 1. Okay, so we know because our larger denominator is under the x, we know that we are going to be, it's going to be horizontal. And again, y'all, I'm a visual learner, and sometimes I just have to plot it. So we do know that the center, one of the things that we need to find is we take it by getting the opposite of our points inside. So I have negative 4 and positive 3. All right, so we know our vertices are going to go out in the x direction. So if you need to plot it, so we're over here at negative 4, positive 3. So we're going to go right 5 and left 5. And so again, another way to think about this is that you're changing the x value by 5. So if we went left 5, that would be negative 9, 3. And if we went right 5, that would be 1, 3. And then our co-vertices, we're going to be going up or down 3. So again, our x won't change in that time. So I have a negative 3, and if I go up 3, that would be 6. And then I have negative 4, and if I go down 3 from my center, that would give me 0. And then I need my foci, so I'm going go ahead and write that in. So I'm going to go over here. I got c squared is equal to, now remember, this is an ellipse. The parentheses are added, so the a squared and the b squared are subtracted. So that's 25 minus 9, c squared equals 16, square root, c is equal to 4. So that means from my center, I'm going to go out 4 in the x and y, in the x direction. So if I go 4 to the left from here, I'm going to be at negative 8, 3. And if I go 4 to the right, I'm going to be at 0, 3. And those are our foci. And then it asks for the length of the major axis is the last thing we need. So major axis. Now remember, the major axis is 2 times A. So here we have 2 times A would be 5. So 2 times 5 is 10. So the length of our major axis, we can say length of major axis is 10. And that is all of that. All right, that wraps up our unit on conics, and we'll be reviewing and testing the next few days.